In this video, we're going to be talking about the Quiz 3 review. We've gone through a lot of stuff, and I know some of you guys are having questions, so hopefully you'll find this video beneficial for you. All right, let's get started. All right, so complete the following task digraph. All right, so what we have here is a task graph from start to finish with everything in between, and we've got to put all this information down. Now, the first two columns here, honestly, to get them, all I got to do is look. All right, so I got to look at prerequisite task. I got to look at the time. Now, the time, very simply, is the time that it takes to do a task. So, like for example, notice on start's arrow, there's a zero. There's a zero. All right, so whatever is on the arrow is the time. So, like for example, A, if you notice that there's an 8 on A, so I'm going to put 8 right there. Okay, so follow this same procedure. So A has an 8 on its arrow, B has a 5, C has a 6, let's see, D has a 3, E has a 9, and then lastly F has a 4. All right. Now the next thing is prerequisite task. Notice again, I just said look at it. All you got to look at what is pointing. So what is pointing? So like for example, looking at A, what's pointing at A? Well, that's start. So that means for A is going to be a none. All right. Notice B, what's pointing at it? Well, what's pointing at it is start. So that's another none. All right. Looking at C, notice what is pointing at C? Well, B is pointing at C. So the prerequisite is B. All right, let's see what is next. D. Hey, I got two things pointing at D. That's C, and that's B. All right, so that's going to be BC. All right. Let's see. E is next. E is right here, but what's pointing at E? Well, that's A. A is pointing at E, so that will be the prerequisite task. And then lastly, F. Oh, I got three things pointing at F. All right, let's see. There's F. So the three things pointing at F are E, C, and D. All right, so C, D, and E. All right, next is going to be the EST. All right, so let me clean this up. All right, now the EST is something that you're actually going to have to, now you're going to have to work out the EST. First two are observational, and then this is not working. You got to work it out. All right, so what we have here is start. A can start at 0, B can start at 0. Because why? Because the time before them starts at 0. All right, now let's look at C. B starts at the 0-minute mark. It takes 5 minutes. C can be there in 5 minutes. Or B can be at C in 5 minutes. All right, let's just look at E. A starts at the 0-minute mark. It takes 8 minutes. E can start at 8 minutes. All right, now where it gets a little more challenging is when you start having someone like D. Notice what we have here, we have two things going to D. So we have B that can be to D. So let's see, if B left and went to D, it can be there at 5 minutes. But here's the problem. C is leaving at 5 minutes, and it takes 6 minutes, so that's 11. So if there's ever a situation where you have an 11 and 5, you always got to take the longest number. All right, same thing for F. Look at F here. It's got three things. It's got E, it's got C, and D. All right. So if E, let me do this different color here. If E had 8 minutes, or that's when it started, and it took 9 minutes to do whatever it is, that would be 17. If C starts at 5 minutes, it takes 6 minutes. That takes 11. Well, if D starts at 11 minutes, it takes 3 minutes. D can be at F at 14. So the question is, when can each person be there? Or when can F start? And it's always going to be the largest number, 17. And then the finish is 21. Remember, this is the minimal project time. All right, so it's the minimal project time. So there's all my numbers. So I'm just going to put all my numbers into my chart right here. All right, so let's see, A and B were 0. So A and B is 0. All right, C is a 5. And of course, nothing goes there for a start. Let's see, D had an EST of 11. E had 8 and 17. All right. 11, E had 8, and F had, I believe it was 17. All right. Now, once we do all this, let me clean this up for 1 second. Now I have to find the critical paths. All right, now the critical paths you'll be highlighting. So, oh, the minimum project time, sorry. 21, there it is. All right, so now we got to find the critical path. Now the critical path is just highlighting how you got the number. So like, for example, A ended up with 0. How did I get that? Because it came from start. Same thing from B. All right, now look at C here. C became 5. Why? Because start, or not start, but B had 5. All right, same thing for E. If you notice it's 8 minutes, I got that through E. And what we're trying to do is find a path that takes us to the finish. Now, this is where things get a little trickier, if you want to call it that. D had 2 arrows. All right, so you're either going to highlight this or you're going to highlight this. All right, now the question is, how did you get 11? Did B make D 11 or did C make D 11? Well, we'll see. 5, 6, 11. All right, now next is looking at F. Again, you have 3 arrows, so you're either going to highlight this, you're going to highlight this, or you're going to highlight this. It all depends. How did F get 17? Well, let's see. D was 11 plus 3. That doesn't give me 17. C was 5, 6. That doesn't give me 17. But oh, look at E. 8, 9. Those two add. There you go. And then finally finish. That's it. So my minimum project time, I'm just going to go ahead and type it right here just because I don't want to scroll up and down. So it's going to be start, A, E, F, finish. All right? So start, A, E, F, finish. That is my critical path because that was the only one, and I will highlight this again just in case you need to see it. Start, A, E, F, finish. There we go. All right, next we'll find the degree of each vertex. At this point in time, this should be relatively easy for you. A, let's see, has a degree of, let's see, 1, 2, 3, 4, 5. Has 5. 5 edges, and that loop counts as 2. B has 1, 2, 3, 4, 5, 6. Let's see, C has 1, 2, 3, 4, 5. D has 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. For E, that should be easy. And then I think I threw another question. Oh, the total degrees of the graph. Very simple. I'm just going to add all this up. So let's see, that's 10. Let's see, 10. I believe that's going to be 26. Let's see, that's 5. That's 11 plus 2. Yeah, okay. I'm going with 26. All right, so finding the JC matrix. Now remember, in the JC matrix, you're just writing how many times things are connected. So like, for example, using the A column. All right, using the A column. If you notice that, let's see, A is connected. It has no loops, so it's a 0. A is connected to B 1 time. That's a 1. A is connected to C. A is connected to E, and it's not connected to D. All right, so 0, 1. All right. Now, here's a little trick. I don't know if you've picked up on this, but whatever the row is, that's what the column's going to be. So that will be 0, 1, 1, 0, 1. All right. So, I mean, that's a little trick just in case if you wanted to save yourself a little bit of time. All right. So next one is, I'll just go ahead and move them. All right. So let's see, B, let's see, B to A, we already have it written down. There's no loop for B. C, let's see, B and C are connected twice. Let's see, B and D, they're connected once. Let's see, B and E, let's see. I think B and E, that is going to be 1 time. All right, so that's a 2, 1, 1. And again, you don't have to do it this way. I'm doing this to save a little time and show me something different here. All right, looking at C here, there's no loop on C, so that's a 0. Let's see, C to D situation. Is C connected to D? Yep, 1 time. Let's see, and then C to E, let's see, that is a 1 time. So 0, 1, 1. Moving over. right, so let's see, that is let's see, D to D. Oh, there's two loops there. All right, and then D to E. Is D to E connected? Yep, that's one time. So 2, 1. And then if you do it this way, the only thing that you need to highlight on the last page is going to be the loop, if there is one, for E. Now, what is the degree of vertex D? 1, 2, 3, 4, 5, 6, 7. There we go. All right, complete the following matrix using the graph. All right, digraph. All right, so this is different because now what we have here is arrows. All right, so when we're doing this here, all we're really paying attention to is the arrows leaving. Remember, this is the from, this is the to. All right, so I'll type a little hint here. The little hint is, and that is pay attention to out degree. All right, so that's all you got to do, just pay attention to the out degree. So, for example, hopefully once I show this to you one time, you'll be like, oh, this is so easy. All right, so looking at vertex 0, there's only 3 things leaving vertex 0. All right, so there's an arrow going to 3, there's an arrow going to 1, there's an arrow going to 6. So I'm just going to mark it. 1, 3, 6. Now everything else is going to be zeros. I'm just not going to put zeros because I don't want it to be complicated. All right. Now look at vertex 1. Here it is, right here. There's a lot of things coming to it, but the only things going from it is an arrow to 2 and an arrow to 3. So arrow to 2, arrow to 3. That's it. All right. Vertex 2. All right, so vertex 2, which is right here. Again, a lot of things coming to it, but a lot of things leaving it. All I'm paying attention to is there's a 2 to a 1, 2 to 3. All right, so 2 to a 1, 2 to a 3. That's it. Big old fat matrix, but it's not really being messed with because we're paying attention just to the out degrees. All right, or yeah, the out degrees. All right, so for arrow 3, it's leaving 2, it's leaving 4, so I'm just going to mark it as such. It's leaving 2, it's leaving 4. Again, everything else would be zeros. I'm just not putting zeros on here. All right. Hopefully you're fast forwarding it because you're like, oh, it's so easy now. All right, 4 is going to a 1, going to a 5. I'm going to mark it as much. 4 is going to a 1 and going to a 5. All right, going to picked up vertex 5. 2 arrows leaving it, going to a 2, going to a 6, going to a 2, going to a 6, and then lastly, there we go. Let's try this again. Vertex 6. Notice that there is nothing leaving vertex 6. So that entire blank or that entire row will be nothing but zeros. All right. All right, chromatic number. All right, so chromatic number, I'm just going to go ahead and start. All right, so this vertex right here, I'm going to label a 1. What else can be a 1? Now, obviously, I know way over here can be a 1, but I don't want to jump all the way over to the graph. All right, I want to kind of look at from here moving out. All right, so all right, so let's see. This can be a 1. That can be a 1. I think that's it. All right, and that can be a 1. All right, so I ended up doing that one anyway. All right, so that's 1. So at random, I'm going to make that a 2. This will be a 2. That'll be a 2. We'll make that a 2. All right. That'll be a 3, which means that'll be a 3. All right, so that's a pretty involved chromatic number. So I'm just going to bank with the fact that's going to be a 3. All right. Always do it again, just be on the safe side, but I'm just going to go ahead and say that's going to be a 3. All right, this right here, that'll be a 1. Let's see, what else can be a 1? That can be a 1. That can be a 1. That cannot be a 1 because it's connected that way, but this can be a 1. All right, next will be a 2. That can be a 2. Let's see, that can be a 2. That can be a 2. that can be a 2. This can be a 3. This can be a 3. All right, so this will be a chromatic number 3. All right, next one. All right, just starting at F, I'm going to make that a 1. Let's see, E can be a 1. B can be a 1. A will be a 2. C will be a 2. D will have to be a 3. All right, I'm trying to think if I can do this differently because that. Let's see if I can do this differently. All right, so heck, I can't even remember what I just wrote. All right, so let me make this a 1, which would make this a 1. I think that's it. All right, so C will be a 2. A will be a 2. All right, and then that will be a 3. That will be a 3. All right, I did it twice. It's going to be a 3. All right, construct a digraph. Digraphs are easy. Remember, the arrow is always going to the second letter. So let's see. Let's go make this a little bigger. All right, so what we have here is, let's see, the first one is B to A. So B to A to C, B to C, E to D, C to E, and then D to C. All right, that's it. All right, analyze each graph. All right, so is the graph above a connected graph? So this here, yes, it's a connected graph, but is it I'm sorry. Yes, it's a connected graph. I think this is supposed to be complete. All right, so something's supposed to be complete. Let me see. All right, we're going to say that. With this right here, and then I guess hopefully my one and only typo, complete. All right, now this is a complete graph. All right, so a complete graph means I have all the edges drawn. So if I can draw one edge in this thing, then obviously I know it's not complete. So like, oh, I just see one. That right there, I drew it. So because I had to draw it, I know it's not complete. Now this right here, this is a tricky one. All right, because the way I wrote it, I intentionally tried to trick you on this one. All right, so what we have here is, notice what I'm highlighting. That is not connected to the one up underneath it. So I tried to trick you. All we have is two graphs laying on top of each other. So no. If it's not connected, it cannot be complete. All right. No. All right. Construct with 8 vertices, 5 of the vertices with degree of 1. Now what I told students is go ahead and pre-select what my degree of 1s will be. Those are 5 right there. And then the rest I'm just going to, all right, so let's see. I'm just going to connect everything else. All right. And then I'm just going to connect them. All right. So there we go. There we go. I'm just connecting these at random. There we go. And then lastly, there we go. All right. So I just drew it. 5 of the degrees have a degree of 1, or 5 of the vertices have a degree of 1. Now the next thing is how many total degrees. Let's see. This has a degree of 1. That 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 has a degree of 1. 1, 2, 3. This has a degree of 3. 1, 2, 3. This has a degree of 3. 1, 2, 3. This has a degree of 3. So let's see. That's 9, 10, 11, 12, 13, 14. 14 total degrees. All right. So consider each graph as an Euler path, Euler circuit, so on and so forth. All right. So Euler path, remember, it has to have exactly 2 odd. All right. Vertices. This is even, and anything Hamiltonian is a guess and check. All right. So it's a guess and check. All right. So what we have here is A. That is a degree of 3. So this obviously cannot be an Euler. Let me see if I can rewrite it in a certain way. All right, so it's a little bigger here. Let me pause it. Okay, I went ahead and just put the choices down here. All right, so first off, what we have here is a situation. Vertex A has a degree of 3. The circuit has to have all of them even, so we already know it's not going to be a circuit. All right, next, let's see, that's a degree of 3. Oh, look at that. There's more than 2 odd vertices. That's not going to work. All right. So next is a Hamiltonian path. All right. Now, remember that a Hamiltonian path is I start at one vertex, I end at another, but I can't get back. All right. right, so let's see if I do something like this. There it is. Notice I started at A, ended with D, and I can't go back. So a path, yes it does. Now the next thing, does have a Hamiltonian circuit. Well, again, we're guessing and checking. Look at that. There you go, Hamiltonian circuit. All right, next it's going to be, does this thing have an Euler path? Well, let's go ahead and check all the degrees. So let's see, C has a degree of 4, B has a degree of 4, A has a degree of 4, E has 4, D has 4, F has 2. Let's see, that is all even, so I know a path ain't going to work, but an Euler circuit's going to work. All right, now let's take a look at this Hamiltonian here, and I'm going to guess and check. Let's see if I start with C. Hey, look at that. That works. Hamiltonian path. Let's see if we have a Hamiltonian circuit. Look at there. Started at B, ended with B. Hamiltonian circuit. Check. All right, next one. All right, so again, let's go ahead and deal with the degrees here. So A has a degree of 3. Oh, degree of 3. Circuit's not going to work. B has a degree of 2, C has 1, 2, 3, 4, 5. C has a degree of 5, E has a degree of 3. Man, look at that. 1, 2, 3. That's just 3 odds. So I already know Euler path ain't gonna work. All right, now let's see if we can do a Hamiltonian path. Let's see. If I started with B just because I wanted to. Boom, 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 boom. Oh, that's a path. Started with B. Couldn't get back to it. All right, let's see if I can get. Let's see if I started with B again. Let's see if I can create a circuit here. Uh-oh. I can't do it. Can't go through C. All right, so Hamiltonian path is going to be a no-go. All right, can't do that. All right. All right, so let's see next. I think I gave. Oh, there we go. Here's a digraph here. Put these back. Sorry, I'm just doing a little bit of maintenance, and I'm keeping the clock running, so maybe that's probably not the best thing. I got a lot of these things. Let's see, paste, and then lastly, paste. All right. So this right here, a digraph. Let's see what we have. Digraph is all guess and check. You can't do a, you cannot do a what do you call it? Degrees. Can't do degrees. All right, so let's see. If I start with B, I go down with A, I go down with C, I go back to A, and if I go back to B, uh-oh, I'm stuck. I can't go down to D. I got to follow the arrows. All right, so I believe we are not going to have an Euler circuit. All right, and in fact, I don't even think we're even going to have an Euler path. All right, just kind of looking at it. All right, so let's see if we have a Hamiltonian. So Hamiltonian went there, went there, went there. Awesome. That's my Hamiltonian path. Yay. And I was not able to get anything Euler, so I'm going to cross that out. I should have done that. All right, let's do Hamiltonian here. Let's see, Hamiltonian circuit. Let's see. If I was to, let's see, start at B, I'm going to find myself stuck again. Okay, that doesn't work. Let's try that one. Let's say if I started with C, A, D, B. I can't do it. Can't get back to C. I don't think we're going to be able to have a Hamiltonian circuit. I think it's just Hamiltonian path. All right, next one. All right, so the next one here, let's go ahead and deal with the degrees because it is a graph, not a digraph. So let's see. Just looking at A, 1, 2, 3. Well, that cuts circuit out. B is 1, 2, 3, 4. That works. D is 1, 2, 3. We're good as long as we have no more at 1, 2, 3, 4. All right, that's good. 1, 2, 3, 4, 5. Dang it. That's my third. Can't do that. All right, let's do a Hamiltonian path. So guess and check on Hamiltonian path. As I'm just starting with B because I want to. Well, that's not going to be a path. I can kind of go straight to a circuit. So we obviously know we're going to have a circuit. So let's see if we have a Hamiltonian path, though. All right, let's see. Again, we're just guessing and checking. Let's see. Is there anything? Okay, I think A does not directly touch D, so that might be our ticket. All right, so A, B, C. Oh, there we go. There's my path. There you go. All right, let's see. How many page? What page am I on? Kind of got lost here. All right, so what we have here is another thing that's dealing with, all right, a graph. Let's see, B, 1, 2, 3, 4, 5. That's a degree of 5. Oh, Euler circuit, already not going to work. All right, let's see if the path, let's see, that's a 2, E is 2, D, 1, 2, 3, 4. That's a 4. C is 1, 2, 3. Oh, look at that, exactly 2. We are going to have a path. All right, so finally, starting with C, whipping it around, B, swinging around, A, D, E, back to B. Awesome. All right, Hamiltonian path. Let's see, just starting with A because I wanted to, swing it over, end with E. Yep, that works. Hamiltonian path. All right, let's see if we can have a Hamiltonian circuit. Oh, no, that doesn't work. Let's see. Starting with C. Boom. No. Dang it, that doesn't work either. Huh. Try one more. Nope, doesn't work. All right, so I don't think we have a Hamiltonian circuit, so nope. All right, last one. We're dealing with arrows. All right, dealing with arrows here. Let's see, dealing with arrows again. We're just guess. Let's see, here, there, 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 there. I go ahead and tell you. Look at 6. See how it has 2 arrows going right to it? There's no way to go to 6. So Euler's not going to work. All right, let's see if we can do a Hamiltonian path. All right, Hamiltonian path. Let's see. If I just start with 4, there, there. No, that doesn't work. All right, so maybe if we start, oh, I go ahead and tell you right there, 0. We would have to start at 0 because there's nothing going to 0. So, all right, let's see if we can go there, 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 down there for 5, over there for 2. I don't think I can get to 6. I think that's going to be a problem. Let me try one more time. All right, we know we're going to have to start with 0. All right, so 0. Hold on. 0 to 3 to 4 to 1 to 2. Dang it, I'm stuck. I cannot go to 5 because of that arrow. Yeah, I think that's not. All right, so Hamiltonian path, Hamiltonian circuit. I don't think I was able to make either or. All right. All right, create a graph using a list of vertices. All right. So DA, which is right here, AD, which is back to there, EC, which is right there, AB, which is right there, BD, which is right there, and then lastly A to A, that's a loop situation. All right, there we go. Now, is this graph complete? No, because there's more stuff I can draw. Is it connected? No, because if you notice, let me circle here, E and C are not connected to that triangle thing. All right, analyze the tournament. Who won every game they played? That would be 0, because remember, winners get the arrows leaving the winners. Who lost every game? Let's see, that would be 6 because that's 2 arrows pointing at it. Who lost at least 3 games? Let's see. Well, looking at it, 2 lost 3 games, 3 lost 3 games, 1 lost 3 games. I think that's it. Find the shortest path between B and D. Let's see, B, which is right here, D, which is right here. All right, so let's see, B to C, that would be 5 miles driven. B to A, that would be 6 miles driven. Let's see, C to E, that would be 10, but I can get there faster. Let's see, F would be 9 miles driven. Let's see, E, I believe that's going to be 8. Now, where am I getting these numbers? I should have highlighted right here. Try that fatter highlight. To there, to there, to there. This is to there. And now I need to get to D. Let's see. Looks to be that will be the fastest route. So that will be 10. So it was, I'll get it right. B, A, F, and D. There we go. And I went 10 miles. All right, I think we're on the last page here. Okay, last page. Here we go. Match the following. When you're creating a digraph, you are making directed edges, which are arrows. Creating a tournament, you're making arrows. Creating a digraph again, using different tasks, arrows, and then creating adjacency graph. That would be A. Pretty simple. All right, complete a K7 graph. All right, so K7, everything's got to be connected. All right, so that's 1, 2, 3. I skipped 1 actually. 4, 5, 6. I'm counting as I go because it's just going to be easier. 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, and 21. 21 lines made that. Whew, that's a lot. All right, so how many vertices? Well, let's go and do 21. How many edges? I use 21. How many vertices did the graph have? 1, 2, 3, 4, 7 dots. How many degrees does each graph have? Let's see, everybody's being touched 6 times. And so what is total degrees of the total? It should be total degrees. It should be total degrees. All right, so looking up at the graph, there's 7 vertices and everything has 6 degrees. So that is 7 times 6. I believe that's 42. And there you go. Awesome. I'm done. All right. That was a long video. Hopefully you learned it so where it's time well spent. Let me know if you have any questions. Thank you.